So, this is a topic that I wanted to tackle yesterday, but we needed some graphical help, so here we are today.
Okay.
And I actually tackled it on Twitter on Sunday, but basically we all know that the amount of ice we got in southern coastal Maine was not forecast.
Yep.
And it was not only not forecast by us, but as far as I know, no one.
Yeah.
So
how does that happen?
Exactly. So what happened here exactly? So the place to start is that you almost never get significant icing if you're 31 or 32 degrees, or even 30.
Okay.
Most of our significant icing occurs in the 20s or teens. And the reason for that is when you change the state of an object from liquid to solid, or from liquid to vapor, or solid to vapor, it takes or creates energy. So if you look at this graph, if you go liquid to ice, which is what we're doing with freezing rain, right?
Mm-hmm.
Look in the bottom there. Heat is released into the environment. They call that latent heat. So there's a certain amount of heat that is released when ice is formed. That's the simplest way to put it.
Okay.
So when
Which is such a strange concept, right?
Yeah, totally. No, it is. But that's what happens. And so when you're at 31 or 32 degrees, we were 31 in Portland when most of this icing occurred. When the first layer of ice happens, it releases latent heat to the layer right above it and makes it pretty much impossible for the next layer to create more ice. Okay, so you get one layer of ice and then it can't create another one because of the latent heat that was on top of it, and you go back over to either just a coating or you just start raining again.
Okay.
That's if you're in the 20s or teens, that latent heat doesn't matter. If it's 25 degrees and it raises it another degree or two, who cares? It's still cold enough for freezing rain.
But if you're at 31,
if you're at 31,
yeah, 32,
or 32, you're at 33. Now you can't do it.
Okay.
Now, how did we do it? How did we have significant icing at that temperature? This is where it gets interesting. So I looked outside, saw the freezing rain, looked at 31, and said, how are we doing this? The wind was north at 20 miles an hour. Now, the direction doesn't matter that much as long as it's not off the ocean. But the key is the wind was strong, 20 miles an hour. And what that does is it takes that little layer of latent heat on top of the ice and it whisks it away constantly. And so that makes it such that that latent heat no longer protects that next layer from being created.
Yeah.
And so they just keep stacking and stacking. The other thing that was unique about this is that this is the 1998 ice storm.
Yes.
And just for reference, that shaded area in Maine is 1.5 inches of ice. So it is more than 2 times the highest report we had from this event. But what I want to draw your attention to is on the bottom there, January 4th through January 10th. So most ice events, ice storms, are several day
layers
events
and layers of
where,
ice. Yeah.
where you just keep accreting ice slowly and slowly, and in that case we were in the teens for that event.
Right.
And so this was unique in a lot of ways. And the last thing is the how did we miss it? Computer models, probably this year alone I would say, put out 10 to 12 ice storms in the models that we have had to say, okay, but is that really going to happen?
Those models overestimate.
They overdo it all the
Okay.
time. And so this was a case where there were models that put 0.6 or 0.7 inches of ice out, but we were able to look at the surface temperature and say, okay, at 32 along the
Just
coast,
unlikely.
you're not going to do it.
Yeah.
And 95%, maybe more, you're not going to, but that's how we ended up with the ice. So I'm not sure I would have done anything differently looking at the data that we had at that time, but just so you know, that's how it happened. It's
crazy.
Confusing, a lot of different variables at play.
To make it happen just that way.
Wow.
Yeah.
All right, thanks for explaining.
Yeah.
Thanks, Keith.